Alright guys, now we're up to 8F where we actually use geometric sequences to solve problems that sort of relate to things that happen in real life. Before we look at a couple of those problems though, I want to look at how to use this rule to find out the nth term. So I keep on saying it, if you want to find the 100th term, n would be at 100. If you want to find the 70th term, n would be 70. The reason we have this is it'll take a long time to get up to those terms. So again, here's our rule. A means the first term of the sequence. R is the common ratio, which you might have to find out. And then N is the term that you're actually after. Right, now with this first question here, it's asked us to find the 12th term, T12, if this is our sequence here. Now, it looks like our common ratio is going to be 2 because it's doubling each time. But again, we could find that common ratio by taking any term and then dividing it by the number before it. So I'm going to just randomly choose 40 and we divide it by the term before it, which is 20. So the common ratio is 2. So that's a piece of information that we definitely need. Now you might be like, oh, but we could just keep going and get to 12. Yeah, you probably could. You could go to 160, 320, 640, etc. and get to 12. So 1, 2, 3, 4, 5, 6, 7, 8. We're up to 8. But if it's a really big number, it'll take forever. Even to get to 12, it might take a long time. So we're going to use this. So we want the 12th term, T12, and we need the first term, which is A, and our first term was 5. We need to times it by the common ratio, which is 2. And then we have, in the powers, n minus 1. So that's 12 minus 1. Alright, so that means we've got the 12th term is 5 times 2 to the power of 11. Now you could use your calculator to do that. I don't have my calculator right here, but I'll fill that in maybe later. Alright, now the next thing we need to look at, which you'll see often, is something called percentage change. If the numbers are supposed to increase, then your R value is going to be greater than 1. And if your numbers are supposed to decrease, then your R value is going to be between 0 and 1. Okay, so let's look at this first situational question here. So it says Lilydale Lake in 2021 had an ibis population of 1,000. It's known that their population increases by 7% every year. So because it's supposed to increase, our R value needs to be greater than 1. Find the ibis population in 2026. Right, so we need to work out what our R value is first. So it says increase by 7%. Now, 7% is, in decimals, 0.7. So I'm going to write 0.07. Now, I'm going to write that there, but hopefully we recognize that this is actually wrong. If I times by 0.07, my numbers are going to go down. Remember, the numbers are supposed to increase, so my R is supposed to be greater than 1. So I want that full 100% plus another 7%. Okay, so my R value is actually 1.01 because I want 107% of what I had earlier. So if we change that into decimals, it's actually 1.07. So that's our R value. Another thing that we need is going to be our A value, which is the first term. So it told us that we start with 1,000. And we want to work out what it was like or how many there's going to be in 2026. So our N value, if the first value is in 2021, the 2026 must be 6. Okay, so now we just need to put this stuff into the formula. So the formula was, I'm just going to write it again, Tn equals A times R to the power of n minus 1. So we just need to plug all this stuff in. So we want the 6th term, started with 1,000, we're timesing by 1.07 to the power of n minus 1. So that's 6 minus 1, which is 5. So you could enter this into your calculator, and it should give you the answer, which again I'll come back to in a second. All right, so let's go to the next one, B. It's saying a disease starts to spread in the ibis population, the population that we were talking about earlier. It is causing their numbers to decrease by 5% each year. So up here we were increasing, now we're decreasing. So if we're decreasing, our R value needs to be between 0 and 1. Alright, so again, let's start again. A disease starts to spread in the ibis population. It is causing the numbers to decrease by 5% each year. Find the ibis population in 2025. Alright, so if we start with 100% of the population, but we drop by 5%, that means we're now going to have 95%. So 95% as a decimal would be 0.95. So that's going to be our R value. And that's between 0 and 1, which we wanted before. So our R value is going to be 0.95. Our A value, which is our starting value, I think it's supposed to be 1,000, as before. And we want to find the ibis population in 2025. So we started in 2021. So our N value is going to be, 5. So we want the 5th term. Alright, so let's set our rule up again. So the rule is Tn equals first term times common ratio to the power of n minus 1. So we want T5. The first term's 1,000. Common ratio is 0.95. And our n value is 5 minus 1. So we could enter this into our calculator. And we'd get our answer. So let me just quickly find these answers out. Okay, so this answer was 10,240. That's the 12th term. The next one, if the ibis population was going up, that answer was 1,402.55. But we need to know you can't have 0.55 ibises, so we only have 1,402. That's our answer. And with the last one, when the ibis population was going down, we should have, after those 5 years, 814.51 ibises. But again, you can't have 0.51 ibises. We don't round up, because just because you have half an ibis doesn't mean you have the full one. We go down because you can't have half of one. So the number of ibises we would have would be 814. And we're done. Have a go at those questions. Let me know if you need a hand.